back with some quick math. The question was a grade 11 technical math question concerning angle of inclination. So this is a grade 11 question that I found. We'll discuss this. Let's start by 1.2.1 and we'll go through all of it, although only 1.2.3 really is the angle of inclination. Right. So the first thing, we're dealing with analytical geometry. Analytical geometry, we have shapes inside a Cartesian plane. So this one over here, it's the most basic form. There's only a straight line. Okay, but we could have a complete shape. We could have triangles. We could have parallelograms or whatever inside the Cartesian plane. But for us, for this is quite a simple one. There's just a straight line. Starting with the distance. So let's find the distance of x, z. So xz is going to equal to, right, the distance formula is one that we should know. That's going to be the square root. We're going to have x1 and I'm going to have a minus x2. This is going to be in brackets. It's going to get squared, and then there's going to be a plus in between my brackets, and then y1 minus y2, and all of this gets squared. Okay, let me maybe just make this comment quickly. This x and this y are going to be a coordinate. This x and this y are going to be a coordinate. Right, so let's substitute these quickly. X1, let's assume that is the first value or the first coordinate. So the x value there is -2 minus, let's assume this is the second one. So the x value there is 3. That's going to be squared, plus the y value there is 5 at the first one, and minus the y value. The other one is -3. So minus 3. Okay, let's write it as that for now. But I know that's going to produce a positive. Okay, right. So the rest of this is the calculator work. You're not going to get any marks. You're going to get a mark for formula, substitution, and answer. Okay, so this part you can put straight into a calculator. I don't have my calculator with me, so I'm going to write it out, but you can put this part over here straight in your calculator. Okay, -2 minus 3 is -5. -5 squared is going to give me a 25. Minus is going to give me plus. 5 plus 3 is 8. 8 squared is 64. If I add these, it's going to be square root of 89. So let's leave it at that. I would want to say 89 units because it is a distance that I'm finding. Although if I don't say units, it's not going to be too much of a big deal. Okay, but you are finding a distance. Next, they're asking for m of xz. Okay, and we should know that that small m is referring to gradient. So let's deal with gradient quickly. Gradient is equal to, and then the formula for gradient, remember the y's are always on top. Okay, so it's going to be y2 minus y1 and x2 minus x1. Okay, remember y is always on top. Okay, and then also remember minus is in the middle, because with your midpoint formula you're going to be adding values. With your gradient form, with the distance formula, sometimes you're plussing, sometimes you're minusing. I always make note of the fact for distance that there's a minus inside the bracket and a plus in between the brackets. Okay, and then for my gradient there's a minus in between my values. Okay, let's go check what those coordinates are quickly. So the coordinates are -2 and 5. So this is what I'm going to do, right? When I substitute my coordinate, so my coordinate here for x is -2 and 5. I'm going to go put that coordinate in at the very same time. So the x value is -2. Where do the x's go? They go at the bottom. So I'm going to put a -2 there. And the corresponding y value was 5. So I'm going to put the 5 there. So let's just double check that. -2 and 5. Okay, so now what I did was, this is a coordinate, right? The important part when I do the substitution is that that's a coordinate that joins together. Okay, then we said there needs to be minuses in the middle. Now I need to go plot that other coordinate, which is +3 and -3. So let's go put that other one in there. Positive 3 is the x value, negative 3 is the y value. And again, this joins together as a coordinate. Okay, so this is one coordinate, this is the other coordinate, and there's minuses in the middle. All right, like I mentioned, this calculator work. It's not going to earn you any marks, so just put all of the stuff in the calculator. I don't have mine with me, so I'm just going to do it myself. 5 minus minus is plus. So 5 plus 3 is 8. And minus 2 minus 3 is minus 5. Okay, so we've got the gradient of our line that we have over there. Next, they're asking, let's see quickly if I can erase this that I've written. Okay, cool. Next, they're asking for the angle of inclination. Now, notice this. The angle of inclination is always from the positive x-axis. So that's this one. From the positive x-axis, anti-clockwise to my line. What we notice over here is that that is a obtuse angle bigger than 90. Okay, so let's do our calculations, and we're just going to have to take that into consideration as we do this. I just realized I'm going to need a calculator. Anyway, so let's say this. What you should know is that tan of theta, theta being your angle of inclination, right, is equal to m. So m is your gradient, which we just found. Okay, so tan of theta, angle of inclination, is equal to m. M is the gradient that we have, and the gradient that we found is up there. Okay, so we're going to say tan of theta is equal to, our gradient was minus 8 over 5. Right, so now what we're going to do is we are going to get rid of tan. How do you get rid of tan? You do arctan. So on your calculator, you're going to press shift tan. So theta is going to equal to arctan. And I'm going to ignore this negative, and I'm just going to put the 8 over 5 in my calculator. All right. And then I'm going to get a value. So theta is equal to, now I don't have my calculator with me, so I'm just going to write a random value. Okay, let's assume it's like something like 30 degrees. Okay, this is not the answer, but I don't have my calculator with me, so I'm just putting a random value there. What I'm showing you is that when you do arctan of 8 over 5, you're going to end up with an acute angle. This thing's acute. All right, let's go back to our picture. We said we are supposed to have an obtuse angle. Okay, let's zoom into our picture again here. We said we must have an obtuse angle. So why did I end up with an acute angle? Okay, let me explain. What you should know, that angle that you just found is the angle on this side. If you did include your negative, okay, let's go back over here where we did our calculation. Right, if you included this negative inside your bracket over there, you would have ended up with maybe like a minus 30, still acute, but just negative. And what you should know is that a negative angle simply means that you're moving in a different direction. So whatever angle that you found, right? So it's obviously not the 30. I just put a random value because I don't have my calculator. But whatever value you find is the one on this side. But like we mentioned, the angle of inclination is from the positive x-axis to the line. So it's on that side. That's the angle that I need. But obviously our line is a straight line. And if I have the one on this side and I need theta, which is on this side, I'm simply going to say 180 degrees minus whatever I just found over there. Okay, so let's go back to our calculation over here at the bottom. So if it was 30, right, my random number, then our actual theta value will be 180 degrees minus this acute angle. And then for my random number, I'm going to get 150 degrees, right? And this 150 is the obtuse angle, which is the one that we want, right? Okay, so just take note of this. Tan theta equals m. Tan theta equals m is the equation for your angle of inclination, m being your gradient. Okay, theta over here, remember theta needs to be from the positive x-axis to our line. Okay, I think that's sufficient, right? Anyway, share the video, like the video, and subscribe to the channel.